This is Mrs. Pena. We're going to find complex roots. Solve 7x squared plus 3 equals 2x by using the quadratic formula. In order to use the quadratic formula, we need to set our equation equal to 0 so that we have a 0 on one side. So from the original equation where I had 7x squared plus 3 equals 2x, I'm going to subtract 2x from each side, and I'm going to write it in descending order of exponents. So I'll write 7x squared first minus 2x plus 3 equals 0. The reason why this is important is because our values for a, b, and c in the quadratic formula are going to come from the coefficients of the x squared term, the x term, and the constant term. If you recall, the quadratic formula is x equals the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. I need to find a, b, and c from my problem. In this case, a will be 7, the coefficient of x squared. B will be negative 2, since I'm subtracting 2x. B is the coefficient of x. And c is 3. And I'll take these three values and put them into my quadratic formula in place of a, b, and c. So x will equal the opposite of negative 2 plus or minus, and I needed to recopy this negative sign and then put negative 2 in for b. The square root of, and in parentheses you need to put negative 2 squared, because we're going to multiply negative 2 times negative 2, which will be positive 4, minus 4 times a is 7 times c is 3, all over 2 times 7, replacing 7 in for a. The opposite of negative 2 is 2, plus or minus the square root. Negative 2 squared is 4, minus 4 times 3 is 12, times 7 is 84, so minus 84, all over 2 times 7 is 14. So this simplifies to 2 plus or minus the square root of negative 80, all over 14. I need to simplify the square root of negative 80. So I'm going to go over here. The square root of negative 80 can be looked at as the square root of negative 1 times, and I need to find the largest perfect square that goes into 80. And actually 16 goes into 80 5 times. So I can look at this as the square root of negative 1 is I, the square root of 16 is 4, and radical 5, or the square root of 5, will be left. So I can simplify this to 4i radical 5. And I'll put this in place of the square root of negative 80. So this simplifies to, going back over here, equals, recopy the 2 plus or minus. In place of the square root of negative 80, I'll write 4i radical 5 over 14. Look at the numbers outside of the square root for each term in the numerator and the term in the denominator. This 2 is even, this 4 is even, and 14 is even. If you split this up, you could split it up as 2 over 14 plus or minus 4i radical 5 over 14, and then divide each by 2. Keep in mind, this 14 goes for each term in the numerator and terms being separated by that plus or minus. So this would be 1/7 plus or minus 2i radical 5 over 7. That's your solution, and if you wanted to keep it as one fraction, we can write it as 1 plus or minus 2i radical 5 all over 7, common denominator, and that is the solution for x. Splitting them apart so that you can write them as two solutions if you need to. X equals 1 plus 2I radical 5 over 7, and, because I have two solutions, x equals 1 minus 2I radical 5 over 7.